All right, that's our
Right,
cue
the
to
floor is
start.
yours, Etienne. Yeah.
Thank you. Hello, everybody. I'm happy to see that there's a good quantity of folks on the stream, so nice to meet you all virtually. So my name is Etienne Caron. Today I'm here to talk about Compose, Jetpack Compose. Specifically, we're going to focus on state management with Jetpack. So we'll get to that in a sec, but first I want to say a few thank yous. Of course, thank you to the Android Summit organizers. I mean, I think it's the work of Titan to organize a conference at any point in time, and this year specifically, doing it virtually, I think it requires a great more deal organization than I might ever have. So thank you, thank you, thank you. Really awesome. Thank you to everybody for showing up. And thank you also to the Google GDE program. So I'm part of that program. It's the Google Developer Experts program. For those who don't know what that is, effectively, you get signed up into that after you've been around the community for a few years. People appreciate your contribution. And you basically get into this group where Google backs you to go to conferences or gives you training material or access to different engineers, with the idea that we just bring that back to folks at conferences and online and so on and so forth. So they're always great support. So I want to say a big thank you to them as well. All right, so let's get started. Okay, getting used to my little iPad remote today for a keynote. So what are we doing today? We're going to be taking a look at just move that video here. So we're taking a look at how Jetpack Compose is going to empower us to push the envelope of UI and UX interaction. Another thing we're learning today is all about state management and unidirectional data flow. And also one of the big key points we're touching on today is how Jetpack Compose keeps things efficient while reacting to changes in your application state. So what I do like to touch on before we get started is we're not doing a deep dive into the creating fancy designs on Jetpack Compose. That is definitely not what we're doing today. So I just want a fair warning to everybody. What we are focusing on today, though, is how we're going to be connecting our models to Jetpack Compose and how we push changes into Jetpack Compose and what's involved in that. Now, I've tried to make the talk as agnostic as possible, meaning that it doesn't matter if you're using MVVM, MVI, or any other one of the architecture alphabet soups out there. The core concepts are what we're looking at: how to hook components together, how to stream data into one another, and doing it cleanly. And we're going to look at how to using that with Flow, if we have time, RxJava, and LiveData. So those are the three big ones in the Android community nowadays. So that should cover all our bases. All right, awesome. So as of today, early October, Jetpack Compose is in Alpha 4. So you can try it out if you download Android Studio 4.2 Canary 13. If you've played around with Compose a year ago, you know that you had to basically compile almost your own Android Studio, or at least use a version that was in Google's repos. It was pretty hard. It would break on compile errors all the time. The story's not like that at all nowadays. It's really a lot of fun to play around with Compose. So I suggest you download that Canary build of the Android Studio IDE and just play around with it a little bit. Also, something that's worth mentioning, when Google release alpha libraries, usually it means that they're pretty solid, although that their API is still in flux. So over the last month, we've seen a few things change name, a few things change places, a few function calls get deprecated left and right. But the fundamentals have been here, I would say, since August. So today's a really great day to get into Compose and learn about it, because that knowledge is going to really carry forward. All right, cool. So we're going to start with a practical example. Practical examples, generally speaking, I feel are the best way to learn. So here I framed the talk around this sort of fictitious native e-commerce type product listing app, right? It's a very basic little thing. We're going to be showcasing products. So we're going to work mostly around the idea of showing a product and interacting with that. So we're going to start with a product entity. Now there's already a few things that are specific to Compose here that I think are worth looking into. So as far as like the data itself, it's pretty straightforward, right? There's a UUID, there's a name, a description, an image URL. So we're just going to point to actual images somewhere. And there's a price. In this case, I've kept it long. So decimals baked in, and then we're gonna, well, I'm not covering this in the talk, but that's usually a good way of handling currencies. Since some currencies have different amount of digits that go for the cents and so forth. Now, the other thing that's worth noting, and the key point on this slide really is the immutable annotation right here, and the fact that we're using a data class. So I'm just going to set up my little highlighter here. So this section right here is really the key part. Now, why is this so interesting? But the idea is that, first off, when you're using a data class, right, everything under that data class should be a val. So the data class itself, by definition, is pretty much immutable. Now, the @immutable annotation here is more information for Compose. Like the Compose system can't really necessarily assume things about your classes all that much. So if you give it a hint that this structure is itself immutable, it will help it when it needs to decide on which sections of the screen to redraw when state changes. We're going to dig into that a little bit deeper, but think of immutable, the @immutable annotation, as giving a hint to Compose that you're going to respect a certain contract with your object. Okay, so this is going to be our first composable, the product card. So we're going to dig a little bit into that, but still, like I said, we're going to keep it simple. But it's worth noting what we're looking at, knowing what we're looking at. So the card right here is effectively the whole card itself. It's the wrapper, it's a little white background, and that's where we put our components into. Then we have a column. Column is basically keeping the components organized in so, right? So it's a layout command, effectively. So that's keeping things pretty simple. All right. Then the next step is the next composable is one that's kind of interesting, coil image. So at the base, Compose doesn't come with an easy way to load images off the network, right? It's a UI library, so it doesn't necessarily have to concern itself with that. So Chris Baines has this little plugin library that's an add-on to the coil library, and the coil library is a coroutine-based image loading library. So we get this coil image @composable function that will do all the hard work and hard lifting for us to look up a URL, get the content behind that URL, refresh it, and if that URL is not available or we're waiting on it, it's just going to put a blank space there and make sure that everything works out okay. Right. The other thing we can see with this coil image is all the little parameters here. So if you use the image in Compose, they're pretty much the same components, the same parameters and attributes you would have. So content scale tells the image how to crop. Modifiers allow us to put these nice rounded corners and specify all sorts of things for layout. Next up, we have a little spacer. So that's the space that we see between the cards and the title, the image and the title on the card. And I'm just going to delete a little bit of these things. A little bit messy. And then we have two other parts here, text, two text labels, the title and the description. All right, so that's cool. We're going to get back to how we're distributing content in there in a sec. So next up, we have to talk about the old system. Like, why is there a new system to start with? Why is Jetpack Compose so much better than XML? Well, the thing with XML is that you need to programmatically find references to a component that interests you by calling stuff like find by ID methods, right? When you have this big XML file, what the system will do for you is it takes that, instantiates it into memory for you, and then you need to manually find the parts of that UI layout that interest you, get references to those, and then for those widgets, you need to start calling set methods for every piece of data that you want to set in there. If you need to find out what's currently being held in here, you're also going to use get methods. So the problem is that basically our XML tree is stateful, and that can be a big problem, right? Like if you think about it, it's error prone. Like for example, let's say that you have 3 places on your screen where you're showing the same piece of information, or you're using the same piece of information in 3 different ways, or 4 different ways. So what happens if the UI changes? Are you going to remember that, oh yeah, I have to add that in here? Like there's a solid chance that somebody's going to forget one of those fields that you have to set, just because there's nothing that really explicitly says these fields need this piece of information right now. The other thing that can happen is that you might want to modify on the fly the end memory model of that XML. So maybe you get a system message from the network that says, oh, this segment is not available right now. You need to disable like a section of your UI. All of this you have to deal with manually and besides the UI tree itself. So that's where the error prone really comes in, right? So that's one of the big things that Compose helps us with. If you compare the two approaches, you can see that composable functions, they take in the data that they need and that's it. So if we look at this product card again, you see that the first thing that we pass in is the product attribute right there, right? Now, where do we use it? Well, we use it in a few places. So while we're creating our view hierarchy, we're going to use it here in coil image, where we get an image URL out of the product. And we use it again here for the text title. So the name there is used as the title on the card. And we use it in the third spot right here for the description itself. So what's kind of interesting there is that we're not manipulating directly like that card and trying to find those targets and inject information in there manually. No, what we're doing is that as we're composing the card, we're passing it the information it needs. And as a starting block, that's a lot less error prone than having to, go and splice up all your information in little pieces. Basically, composable functions have their own internal logic, and they're responsible for turning app state, which they receive at the entry point, into a UI. Right. Okay, so the other fun thing about composable functions being written in Kotlin instead of XML is that your composable functions can now be as dynamic as they need to be, right? You can set them up to have really sophisticated behavior. So I took this example here. Let's imagine that we had a product list, right? So we have a product list. Let's say there's 10 different products in there. And we actually want to sort that list by price from cheapest to most expensive. And we're only really interested in our top 2 or top 5, right? In this case, I picked top 2. So I've created this composable called product top list. And as attributes, as parameters, we're passing in the amount of cards that we want from the top of the list. We pass in the list itself, the products, the data, it can change, right? And then in there, what we can do is use Kotlin's functions, collection functions, to filter through the list, order it, and do whatever we want. So here, first we say, okay, we're going to sort by price. Then we're going to take X top amount of cards of products from that list. And to top it all off, for each of the for each of the products that we have filtered that are left over, we will call the product card, which we've seen before, right? So we can leverage, also that's nicely composable right there. We can leverage the card we created in this scenario and in all sorts of other scenarios. And that's about it. Now, a little thing that might be missing, but that you could also do, for example, is decide that in this case, for example, I've put a spacer between each card. I might get fancy and want to say, okay, if it's the last card in the list, I won't put the spacer there for layout purposes. So this is all behavior that you can bake in straight into the composable. It's not going to be spread out across a whole lot of classes that depend on this XML. No, it's all in one place. It's nicely encapsulated, and that's really powerful. Right, so if we go back to our product card now, XML, as I mentioned, when you want to update a widget, you need to change that widget state manually, right? But what's really, really neat about Compose is that when your source data changes, your composable functions are going to be automatically called and updated with that new data. And it's going to be done in a smart way. What do I mean by that? So let's imagine here that our product changed, right? So there's a new copy of product. The whole card changed. Our memory model has changed, and product card gets called with this new product card. So Compose is smart enough when it builds these composable functions and composes them together and builds that reference tree. It's going to be smart enough to go and say, okay, cool. I'm using products here, 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 and I've added a little section from the earlier example, right? We're now using the product price here as well in this outlined button right here, okay? But okay, so Joy Division, that album, it's kind of nice, but as far as like pricing goes, even though it's a vinyl, I find that way too expensive. let's just say, okay, I'm going to sell it to folks. Nobody's buying it anyway because there were 1 million copies of this thing printed. So you can find it all over thrift shops or whatever. So I'm just going to reduce that price to $9.99. How would that work? Well, I would change my memory model. Like I would change my product. That product would somehow, we're going to look into it in a few minutes, but somehow we're going to end up with the product getting updated with that $9.99 price. And what happens then is that Compose is going to look through everything and it's going to smartly decide, well, you know what? I only need to update the outline button. So when recomposition is going to happen and the system, the Compose system detects that there's something to be changed, it's going to take care to only call the outline button composable function to rebuild it again and let it do its own work. And it's going to be smart that way through the whole tree of your view. Right, so in this case, outline button would be called again, and we'd end up with a $9.99 album for our Joy Division album right there. Cool. So those are the big key concepts, right? So there is something that you need to keep in mind though, right? So Compose brings a lot of power. It's smart about how to redistribute your views, mostly because it wants to keep things efficient. Now, there's a few rules and regulations of sorts that you need to follow when you sort of deal with Compose. But the thing is that since the smart recomposition system does things its own way, it can do stuff like skip as many functions as it wants, right? The example I just talked about a second ago, basically, Compose is going to try to do the least amount of work as possible, and that's what we want. Next, you can't actually assume anything about the order that this composable tree of function is going to be called in. And that's a bit of a doozy, right? So if you think about it, it doesn't matter which order it's called in. You shouldn't care. But that also means that if you're affecting any kind of side effects in your functions, if there's any kind of work that impacts other pieces of your app, of your model, that happens while these functions are called, you're going to be in trouble. The other thing is these functions can be called extremely frequently. How can that happen? Well, it's not because your model changes all the time, but if you run an animation, for example, it might need Compose to call back a few sections of your tree repetitively just to find out where things are going to be put. So there's a potential there to have a ton of calls. And even worse, if you will, those calls don't have to happen on the main thread at all. Actually, they're going to happen in parallel. You don't control effectively how these things happen, and those are all performance reasons. So the one simple law, you have to avoid side effects at all costs. If there is any type of state that you're going to be creating in your composable function, it has to be self-contained and effectively invisible to the outside world. So no mutating attributes of your state. You can't be using shared preferences. You don't want to be writing into shared objects in memory. All of these things are big no-nos when you're writing composable functions. The things to look out for and sort of aim for are more things like respecting a unidirectional data flow. We're going to look at what that is in a sec. Having click listeners is actually quite fine. So click listeners, what happens is that they are called from the main thread, which makes sense, right? If you're used to doing registering your old click listeners the old way with XML, that's the same thing. When the click listener is called, it's called as part of the main event thread. And that's pretty much the same thing with Compose. Now, there's 3 other things that are good to know exist, but we're not really covering in today's talk. And that's the remember, mutable state of, and state of functions. So those are 3 functions that you can use to effectively save pieces of information or even give state to your composable function. Again, we don't dig into this, but one example that you could think of is if, for example, you were taking a piece of information from the product, I don't know, the word count of the description and showing that word count next to the description, right? It's a bit of a calculated value. You might want to store that locally in Compose. It's not something you want to put in your model, or maybe you even have like a color indicator depending on, I don't know, battery strength, whatever it is that you're building if it's not a product card. So all these ideas sort of explain that, yes, you might have local state, but that state has to stay local. You can't be leaking it all over the place for the reasons I just mentioned. All right, but like as I said, remember mutable state of and state of are not our targets for today. But it's important that you know they exist because you run quite frequently into cases where you need that kind of functionality. All right, so unidirectional data flow, right? I've mentioned it just earlier. It's a big, serious sounding thing. If you're like, it's also pretty hip nowadays, so there's a solid chance that you already know what I'm talking about. But if you don't, it's an important concept that I need to cover. So the good news is it's not a really complicated one. It's extremely simple, and you're probably already using it in your app. So it's this idea that, and we often talk about unidirectional data flows in the context of a UI loop, as we're showing here. So it's this idea that every app can basically be summed up as follows, right? You have a user. That user is looking at your screen. So you have a display. That display has been updated and is showing information, showing buttons and text views and text edits and whatnot to your user. User sees this, takes that in, says, okay, cool, I want to save my field, or I want to change my first name, or I want to whatever. So these are generating UI events. And these events, once you have them on hand, you need to do something with them. So you're going to want to take these events and trigger changes onto your state. And regardless of how you do this, you have app state somewhere that's going to change based on these events. So once your app state has been updated, and sometimes even the app state can be updated from other sources, right? Like we can get network callbacks and things like that. But effectively, when the state changes, the data will flow into the display, if you will, right? Conceptually, that's what's happening. You're building your display off of your app state data, and we're not really reinventing the wheel here, right? That's naturally what happens when you write an app. So that's effectively what we're talking about. The idea of calling it unidirectional data flow is to sort of minimize the back and forth trips and formalize everything. So the big key takeaway here is that you have these modules, and these modules only sort of send data one way and receive it the other way. Like you're effectively just saying, well, try to modelize your app components as if they were functions a little bit. Like if you think of a function gets attributes and parameters in and outputs a value back out. So we're sort of trying to model that concept with our app, and it's really more of a philosophy on how to keep things organized and clean and neat. All right, so enough with the abstract stuff. Let's get into like really detailed and real life things. So we're going to stick names onto each of these boxes. So here are displays the Compose UI. We've talked about it a bit. We have a good grasp of what that is. The Compose UI will trigger UI event handlers, right? So click listeners and so on and whatnot. And those events, when they happen, they're going to somehow, we're going to look at how, well, impact the model. And our first model is going to be a LiveData implementation. And that one's pretty simple. So, and it's also sort of the first exposure you're going to get to state management in Android if you're starting from scratch, right? It's the level 1 of things. And it's recommended in Android's, Google's Android architecture patterns and so on. So, all right, we're at the 20-minute mark. So I'm going to try to fly through the demo code a little bit. And I'm just telling myself this so I don't forget, because, give me a second, just so I keep, okay. I'm just going to alt tab between those two things so my timers are still running and I don't eat up all my time doing these samples. All right, so the first sample is extremely simple. Now I have to say I've done the cooking show trick a little bit. My code is all pre-cooked and ready to go, but we're still going to go through the steps of adding it to an app. So our app is already there. It's got a bit of DI in there. We're not really going to look at that, but okay. So just organize my things a little bit. It'll go much better. Okay, right, cool. So first we're going to look at the actual view model that we want to implement. Right, so I already have a view model class in here. Oh, and by the way, give me a shout out if that font is too small. I've already ran through it once today on Zoom. Most people told me the font was fine, but if anybody's having trouble seeing, I'd really appreciate a heads up. All right, so let's jump into our simple product view model. So if you're a bit familiar with LiveData, well, well, anyway, I'm just gonna go straight ahead and show you how we're going to do things. So I'm going to do a little bit of copy paste here and go quickly over each, but still going to explain what each piece does. So LiveData are effectively these objects that hold a piece of data in there that you can change that data and reassign that value, and then you can have listeners, multiple listeners, you don't really care how many, that can look at the changes on that information and react to it. So that's effectively unidirectional data flow right there. So in this case, though, what we want to do is that we want to make sure that the first that product the first one is mutable, right? We want to be able to write in it, but we don't want to expose the world to that. We don't want just anybody to be writing in there and overwriting the model. We want to keep a little bit of control on that. So we first, though, create the mutable live data that backs everything. We give it an initial state. So if you ever do go see that code, you're going to see that the stately product's just this constant list of mock product data that I've prepared ahead of time. So we're just going to take the first example out of that list to work with today. Now, so that we don't inadvertently allow our users to, our developers to shoot themselves in the foot, we're just going to do this here. We're going to expose publicly only a live data that is non-mutable. So this is a read-only live data that we're exposing to anybody that's consuming that view model. And then so that we are actually allowing a few changes to go in, what we're going to add now is like an official API method, an official API function, sorry, called onNameChangeEvent. That one takes a string, and then whenever the users are changing a little bit the model itself, then we're going to update that here through that. Right, so and then what you can see here is that we're calling the product value, we're assigning it, and we're calling our private copy. And yeah, it's worth mentioning here, how do we actually change our data class? Because if you remember, our product is actually an immutable data class, and it's even flagged to Compose as such. So how can we apply changes to that? Well, that's why live data are important here. What you do is you take your old product, right, and you take the piece of information that you want to change, the name, and you create a copy of that product with only one change, the name. We're getting the new name with the same exact information in all the other fields as we had earlier. Now, one of the little flaws of live data is that because they're sort of nullable by default, you get all these little Kotlin checks with question marks and nullability checks left and right. That's sort of one of the downsides of using live data. They're not ideal really for a lot of things, but they're simple to use, and I mean, they're a perfectly good starting point. All right, so we have our view model. How do we use it? Well, to start with, we have to create we have to create our new card, a new composable UI element. So I'm going to create that file here right now, and we're going to call it a live data example. So that's going to be a composable. Oh, that's great. Somebody's car alarms just started going. Anyway, hopefully that's not too loud for folks on the stream. All right, cool. So I've created this class. And okay, here we go. So very quickly, what do we have here? So our, oh yeah, we do have to add one thing. Nope, not that. So there's a little bug here, and let me just fix that very quickly. I believe it's something like, no. All right, okay, I'll just explain what I'm doing here. Sorry for the silent mode. So we're seeing a little error here, but I'll go through what this is and fix the error as we go. So the live data example composable, first off, what we're going to do, and it's a bit different than the other examples I have today, but first off, it's possible for us thanks to, what's it called again? Yes, thanks to this import right here, the view interop view model that you can see right there. Thanks to this, we're able to grab a view model of a specific type straight from the composable function. So this import is what gives us the view model function that will look at the type of the value we're trying to attribute and go and dig into the view model and the lifecycle stuff from Google, dig out the proper view model and give it to the composable. So that's the first step. The second step that's failing right here, and I'm just gonna jump and get my fix right there, is that we're trying to get the live data and turn it into a piece of a value called product that the composable is going to be able to deal with. And now the reason that's a bit glitchy right now is because that's a special extension function that's being provided to us by Google. And yeah, and then that's sort of part of being in the alpha release. Some of these things don't automatically import in a nice way. So if you've seen, I've just added this get value import, and now the compiler stops, Android Studio stops complaining. And what's happening here is that we're taking the product's live data right there. We're calling observe on state on it. Sorry about that. right here. And what that does is that this is what sort of allows us to tie together the LiveData and the composable. Now we do have to give it an initial state right here. And the rest of this is fairly straightforward. We have a product card that we've used earlier, and we have a text field, which is how we're going to edit. So I'm just going to run this and show you what that looks like. So I've just hit run. I'm running it on my personal device. It's kind of nice now that we can run debug over Wi-Fi as a side note. So this is started. We're not seeing anything. And why? Oh, it's because I've made a mistake. We do need to make sure to include and import that new composable function we've created. So it's thankfully pretty straightforward. You just need to add it here in our set content block. And from that, let me add that little curly brace that went away there. We can run it again and we'll get our result. So the app is popping up. We should see a card now. Yay, good, things work. Probably that delay is the system dealing with loading that image, or just, well, I can't speak to the delay really. We're not going to do profiling here today. All right, so we have the Pocket Watch card right there. We can see the pricing. It's loaded up nicely. Now what we've added, and to demo our stream, is that we've added this editor here, right? And so it might be worth really noting how we're pulling off this trick. Like, if you look at the text field right here, we have an on value change item that we're assigning. So that's the click listener, or not the click listener, but the edit listener, right? So anytime the text field changes, and we're going to do something right now, this will call the view model on name change event function that we added, and it's going to change the information. So as you can see, when I edit, I can see the title change and everything's good. So that's our first demo. That's LiveData. Pretty simple, right? Cool. It's pretty simple, but it has its limitations, as I've mentioned, right? It's not necessarily the most fancy system. And a lot of developers, me included, kind of appreciate still the use of a little thing called RxJava right there. So how do you do the equivalent thing with RxJava? That's like something we're going to look at right now. I'm just going to look at time right now. So we're at a half-hour mark. Okay, so we should be able to fly into the RxJava stuff pretty quickly. Honestly, I suspect we're not going to get through the whole flow example. I just want to call that out right now. But well, let's just get started with the RxJava, and then we'll see where we are. All right, so cool. So to get through that sample, I just need to, a little second to organize myself. It pays off in time afterwards. Okay. So it's worth noting how I'm doing this. In fact, if you're going to look at the sample code afterwards, I've organized these code examples in branches. So there's an example 1, 2, and 3. If ever you go see the repo and the links I gave at the start, you're going to find each of the steps, and you'll be able to go through the same work that I've just done myself. Oh yeah, and then pro tip, when you want to do compare between different branches, what you want to do is go in here and select the top part of your project, like I'm doing, then mention which branch you want to compare against. And here we're going to get started with that. Okay. So when I'm doing, there's quite a few things that we need to add. So I need to give a little disclaimer here. The RxJava version I'm doing is more work, but the work that we're adding right now is really what makes it also a lot more solid than LiveData. So what do I mean by that? Well, we're going to be using something called a model store, a state store. But before we can use that, I need to explain actually pretty simple little concept called reducers. So what's a reducer and how do you make one? How do you build one? So the idea of a reducer, if you've done a little bit of reactive or RxJava, you might have used an operator called scan. Or if you think back onto the copy function that we were calling on data classes earlier, that's effectively what we're playing with here. So a reducer at its simplest form is this. It is a function that takes a current state of any type, in this case a generic type S, and returns a new state. So if you think of the copy operator, it's basically what we're trying to do is officialize that signature. What we're saying is, cool, we're going to create these functions called reducers, and these reducers take in a current state, do some work on it, and return a new state. All right, pretty straightforward. All right, so how do we use this? What is that for? So the idea is that we use it with something called a model store, in this case, an observable model store. I'm spoiler, we're not going to get through this whole thing, I think, on time, but the idea is that it's quite possible to create flow-backed model stores. It's actually just as easy as doing it with RxJava, so that's worth noting. But in this specific case, we're going to build an RxJava one. And okay, so I'm going to skip a few things here. Like typically, I like to explain how the internals of a model store actually work. But really, what you need to think of it as in general is it stores a piece of information. It's right there in the name, right? And then what you need to focus then after that, instead of the internals, is how you use that. And then we're going to add two functions here that are going to make that pretty clear. So that's all there is to a model store implementation. Now, first little bit of code is a bit hard to explain in a nice, tidy way if you've not done RxJava before, but using it is pretty straightforward. So there's an input side and an output side to this model store. So when you want to make some changes to the information that is stored in the model store, what you want to call is the function process. And you pass in a function into that function. And that's where it gets a little bit tricky for people who are not used to this pattern yet. But effectively, what we're doing is we're creating this model store and we're allowing other parts of the application to describe the work that's going to happen to change what's being held into this model store. But we're not executing it right away. We're passing that command along the system. So that's why we're able to do things like take compose, create a piece of work that's going to be applied somewhere else that we don't know much about, pass that along, and then eventually the model gets that piece of work, that receiver, applies it on its own internal state. And when that's done, the next step is it will be broadcasted, that change, to all its subscribers. So what do I mean by subscribers? Well, and what we have here, the second function right here is model state. That function takes no parameters whatsoever, but it returns an observable. So if you're not familiar with RxJava, observables are very much like LiveData. They are streams of information. And this particular model state observable, the way it works is whenever you subscribe to it, you're going to get the current stored information in the model store right away. The current state is going to be provided to you immediately. And as long as that subscription is alive, you're going to get every little piece of information that follows subsequently. So if you think of it from the Jetpack Compose term, Jetpack Compose, when it subscribes to that model flow, that model state observable, it's going to be able to be kept aware of all the changes that are coming in and update itself. All right, so we're actually going to jump to that right now. Oh, wait, before we do that though, yeah, there's like, we need to actually implement this. So the model store here is generic, as you might have noticed, right? It's using a type S. So we can't actually do something generic, that generic. So what we're going to do is we're going to make it into a proper implementation. Thankfully, that's really, really simple. So all you need to basically say is what type of observable model store am I trying to build here? So we're building one that's holding on to a piece of product, like that's our piece of state, the product. Also, we need to provide it with an initial starting state. So we're going to have our second stately product here that's going to be used. And that's it. We're ready to use this. So next up, we want to be looking at, right, we're going to look at actually implementing this. So just toggle back with, oh, I lost my timer, didn't I? Yeah, all right. I trust that I will be stopped by our nice MCs whenever I go over time. All right, so, but meanwhile, let's jump into the main activity itself, right? And we're gonna start implementing what we need. So before we get into the actual big composable that subscribes to our model store, I'm gonna create a few utilitarian ones. I'm gonna go really quickly here, just fly into that and explain them fairly quickly. So I'm just gonna jump, sorry, I'm doing that work off screen, here, back on screen. So I've just added these two composable functions right here. There's one for name edit field. It's very similar to what we had earlier for the Pocket Watch, which is still on screen right there, the edit field right there. The only little difference is that instead of directly hooking into the live data, I'm making it a bit more generic. This name edit field now is gonna get past a listener that it's gonna assign on each value change. Now, the next one that's kind of interest is a button. We just want to be able to increment and decrement the price in this specific example. So we're going to create a generic button that takes a label and a click listener again, just to keep that tidy on the boilerplate side of things. And that's that. So, okay, we're going to jump. Well, before we jump to the actual card, I'm going to add a little bit of code here, which I would typically put in the different class if I was, making a bigger app, make it a bit tidier. But like we're just going to look at that right now and just stick it in the main activity. These are functions. Everything's functional, doesn't have state, so we're in good shape. Somehow my phone decided that it was, oh yeah, I see. I believe that we're looking at my phone decided to go into battery saver mode. So I'm just going to connect that before we get into trouble. There we go. All right, so all right, so the main activity. So yeah, I've just added these two functions right here. And these two functions are effectively what makes the bridge between our UI events and our model store. So that's where we're going to declare what kind of work we want to execute. So here we have two operations that we want to do. We want to be able to change the name. So how does that work? Where we create that reducer right here that takes the old state. Even I could make it an explicit one. So this say is the old product, if you will, right? And then we create a copy of that, but we create and make a new one just by changing the name. So by calling copy here and passing it a new name, we've created a new product, a new name. Same thing here. I'm not going to redo the renaming exercise. The same concept here, right there. Whenever we do a price change, we want to change the price from the old product and turning it and create a new product with a new price. Now, the slight difference here is that we're reusing the price of the old product and adding and decreasing it, right? So small nuance, but that's kind of interesting to know and understand that that's the kind of thing you want to do. All right, so now we have the glue ready that's going to stick our composable to our model store. So we're going to add that right there, and we're going to close on this, I think, but I'll check on time when we're done. All right, so quickly add this right there. All right, our composable itself. So how does this guy work? Well, simply put, it takes two parameters now. So it's a little bit tidier, right? So we first take our input, if you will. So we have our subscription here. So we're going to look at how that works, but subscribe as state really might be better put as state of product. Like I should actually rename that. Because at this point, what's kind of interesting you might note is that there's nothing specifically RxJava about this implementation at all, right? The composable itself doesn't really know what it's subscribing to. We're using a compose construct called state, and state holds a product, and state is smart enough to know when things change and to keep compose updated on those changes. So by getting a reference to product, if I add the type here, we're going to see this is a product. But thanks to that state wrapper, it's a smart product, and it will cause a recomposition whenever the product changes. And the rest of the code is fairly straightforward. Now, it's worth mentioning here, when we create the name edit field here, and the on value change is in this lambda right there. So this is how we hook our glue code and into our model store. So we have this processor function that we're going to pass in that I'm going to code in a second that you'll see. But we're just passing, what events we basically want to take place or what actions we want to see happen onto our model, and we hook those up to the button. So what's kind of interesting here is that there's a nice clear-cut difference here. All right, so let's just look at the glue code and execute it, and we'll look at time at that spot. All right, so here I want to create my RxJava example card, and then to pass in what we're going to pass in, I'm just going to refer to my notes here just to go quicker, not to waste anybody's time. But right, so first off, we have the product observable store. Now we do need to actually get an instance of that. That's very simple. That's, again, a bit of the cooking show part. We have a DI set up already to give us the singleton. So it's worth noting here, though, is that the product observable store is like a unique copy app level singleton scoped. And that's actually fine. That's something I've used in production. You have to look at it as an in-memory copy. there's ways of taking that in-memory copy and making sure it gets serialized to disk or whatever is your medium of choice for as a repository. But right, so this one is there, we get that. And then from there, first off, we get our subscription, our inputs. So we take the observable store, we call the model state on it, which gives us our RxJava observable. And this right here is the glue code with Compose. This is a function that Compose gives us, an extension function. We subscribe to an observable as state. We have to pass it in again an initial value. That's just how Compose is. And to be honest, I have questions about that. But anyway, let's not get into that. That's how that's made. And this will give us our state of product. So right there, we've abstracted from Compose the RxJava details, and we just gave it something that changes over time, and Compose is happy with that. On the flip side, we just want to also take events from Compose and shove them and pass them on to the store. And that's also pretty simple. Like, as you might have noticed earlier, our composable function is expecting a reducer callback of sorts, like something to put reducers into. And what that is the actual process input function that we saw on our store. And that's it. So we're going to run that, and then I'm going to go and check time. So started the execution of this. And if memory serves, I'm sure there's like a small problem that I'm forgetting about right now, but we'll see. Oh, we're good. All right, cool. So we have it. I'm just going to quickly demo that things actually indeed do work. So if we edit the field, much like earlier, we can just say, okay, cool. That's like the second estate on the island, let's say. And then we can start pressing on those buttons and start, we're going to start seeing the price changing. So it's maybe not that obvious, but I'm having really butterfingers today, or there's something weird with the listeners. But no, I think there's actually something weird with my listeners. All right, I got it now. So anyway, when you increase the price right there, I think my phone's just not happy with me today, but you can see the price incrementing. Yeah, I think something's kind of fishy with the phone. Anyway, trust me, this worked. Somehow everything is slowing down right now, which is probably a sign I should stop. All right, I'm just going to go back to slides very quickly. All right, so that was our RxJava example. I'm going to skip over, because I think we're at the 40-minute mark, so I'm going to skip entirely over the flow example. I will mention this for people who want to look into it after the talk. The flow example that I have on the repo is actually a lot more complex than the RxJava example we just looked at. I like to think of reactive architectures in 3 tiers, regardless of MVI, MVVM, or whatever. I like to think of things like, if you look at the LiveData example that we had earlier, that's the simplest object store that you can get, and that's perfectly fine for some use cases. The second one, which I like a lot better, is this idea of the model store as an app-level singleton that can be used to orchestrate a lot of things. I like it because it abstracts away from all the Android lifecycle events, and so it sort of allows you to write models and domain logic that is abstract and decoupled from Android. And the third level of things is starting to use state machines in your model stores. So if you're familiar with Redux, that's probably going to ring a few bells. But at the end of the day, we don't have time for that. But I encourage you to look into it. I have done a few other talks on MVI and talked about state machines and how you can use them to sort of better watch against cases where if you have operations being applied onto your model store and you have no rules to sort of keep things straight, you can still get into cases where your state is going to be incoherent. So those are just like techniques I like to use to guard against that. So I encourage you to check out the repo and look into my third example, which is all about state machines and the use of flow as a storage. So with that, I'm going to say a big thank you to everybody. I really appreciate the chance to speak, especially in those trying times. And I hope you enjoyed it. I'm going to be available for all the questions in the world on Slack right after this. And I'm going to stop on this reference slide. So again, thank you very much.
Thank you, Etienne. That was a wonderful talk.
Awesome.
Yeah, we did go over time a little bit. No worries. Do you have a few minutes for some questions?
Yeah, okay. So we can take some live on the chat, I would think.
Yeah, folks already, first of all, they said that the link is not working. It's
Oh,
showing
okay. I'll go
404.
and check that. Okay. I'll go and double check on that right now. Sorry, I'm just finding my way on Zoom. Okay, cool. Oh yeah, lots of questions. Cool. So do the branch links not work? Oh yeah, what's going on there? Okay. Give me a chance to. I'm just gonna quickly fix that. Ah, yes, of course. There's a tree. There's a little tree bit missing. Let me just copy paste that into the chat, and then I'll look at the actual questions themselves. I'm totally lost with this Zoom interface right now. Okay, there's the chat. What a noob. Okay, so yeah, just basically that link, and then I guess manually those three should be valid. Okay, cool. Right. Sorry about this with the links. So questions in the chat, right?
Correct. There's a few questions in the chat. But
right. So yeah. How much time are we over on time? We should stop, or?
I was told that I can keep this line open.
Okay.
If people want to join other sessions, they can leave this session and join the other one.
Right,
So,
and then if anybody leaves and still has their question unanswered, feel free to ping me on Slack after. I'll keep an eye out. And right now, I'll answer then the questions on the channel, on the chat. So, okay. So there's a question. Yes.
Sorry, there's a question by Thomas Sunderland.
Right.
In regards to the power tool.
Right. So the question is basically, are there preview tools that allow us to see our composables as we build them? And yes, they are. There are. I'm still in the stream, so I guess I could always get into that and show one. Wait. Oh, it's funny. My editor is a bit wonky right now. But yes, so the answer is yes, there are some preview tools. For some reason, though, they're not showing right now, which is like interesting. But yes, you can sort of toggle your window in between edit mode and yeah, just because we're talking about it, it doesn't work right now. Anyway, so if you look at the editor, like you'll have a pane where you can say, I want to see the code, I want to see the code and the previews, and oh yeah, I think I know why. So the reason we're not seeing any previews is I took all of those out in preparation for the talk. But here's an example. So right here, I have a card that I didn't go through, which is the product top list. I've talked about it at the beginning of the talk, the one where I filter things from a bigger list. So here you can see the affordances at the top: code, split, and design. So if you click on split right here, you can see this activate, and we see the preview right here for the two cards in the pricing order and everything. The reason we're not seeing any images right there is because I'm actually trying to load them from the network, and while in preview mode, that's not available. But yeah, so we do get this view, and what's interesting here too is like, I don't know, I'll make an absurd change, but there's this option where if you look at the little icon here, there's a build and refresh, but there's also a build on save. So whenever I save the layout, not even the layout, but a composable function that's linked to a preview, it's going to automatically refresh everything. So we see right now it's actually rebuilding everything on the fly. And I can't say that I notice if the padding has changed, but it should have. So the space modifier somewhere in there should have become 14 dp instead of whatever it was before. So that works relatively well. Similar to the XML, sometimes it breaks, like for example, when you're trying to load a resource off network, but that should actually be fairly rare in the case of Compose, so yeah. All right, so same vein from Thomas. So if we have an existing sophisticated theme structure, how does that translate to the new composable UI? Would we need to recreate them? So it's a bit beyond the core of my talk, and not that I'm not going to answer the question. I have like a little example. What I actually do recommend is you check out one of the talks tomorrow. I forget the exact title. Building with Compose. He's actually someone I've linked into my slides. So if you look, Vinay Gaba is giving a talk tomorrow about this very repo, the Learn Jetpack Compose by example. So he's going to go, I believe, very deep into all the different UI options and all of the good UX stuff that I did not cover purposefully. So I recommend you check that out. But meanwhile, the way theming works at the very basic level is that if I go back to my main activity right here, we can see that I was wrapping my components with this My Compose theme. And so that's actually something that you define yourself and that you can reuse all over the place. So it's the quick answer is via composition. And that seems to be all the questions we had. So if anybody's still there, ask me questions on Slack. And actually, can I see if anybody's still on the call? Yeah, there seems to be a lot of participants. So anyway, if you want to ask another question, I'm here for another couple minutes. But if you prefer on Slack, which may be easier to track, and I'll jump on that right now. I'm going to say again, thank you for everyone for watching. Really appreciate the chance to talk, and I had a blast. Thanks.
Thank you.